Good evening. As you all are aware that present situation is not so good, and most of us are staying in our home. You all are aware that whole world is facing a difficult situation, and India is also not untouched with that difficult situation. Of course, I am saying about the coronavirus outbreak which has taken place in our country too, which has made our Honorable Prime Minister Sri Narendra Modi ji to take tough decisions in order to prevent community spread of this coronavirus. It's not that he has not got pain or he is feeling a very great pleasure in keeping all the people confined in their homes. Absolutely, it's not true. He is also having a deep pain, great pain. But in order to save our country, in order to save our people from this corona outbreak, this type of tough decisions, being a leader of the country, being the head of this country, he has to take, and he has taken. We all have a deep respect for his decisions, and we are following the guidelines issued by government, central government, state government, district officials time to time. So it's my kind request to all students also to keep themselves in their home, and simultaneously they can enhance their knowledge through various other sources, various other means. It's not that only physical availability of a teacher and students only is the way by which one can transfer his knowledge. Nowadays, due to enhancement of technology, advancement of technology, we are in a position to have virtual contact with each other. So, as I have not introduced you, myself, Professor Sanjay Singh, working in Department of Aeronautical Engineering of Vinayaka Missions, Kirupananda Variyar Engineering College, Shalem. So, for my students and even for others who are aeronautical engineering students who are in home now, I feel that I should have contact with my students and I should do something to enhance their knowledge. What I was doing physically, making myself available in the classroom and having an interaction with them. So now at present, the situation, that type of availability cannot be made, as we all are aware and as I have already discussed. So I have made this small video where I am going to explain about the engines which are fitted in aircrafts. So today I will have a discussion on turbojet engine especially, and later on I will be coming with some another type of engines. I am very much thankful to my Pro-Chancellor, Datto Sri Dr. S. Sarvanan of Vinayaka Missions Research Foundation deemed to be university, and my principal Dr. A. Nagappan of Vinayaka Missions Krupananda Vriyar Engineering College, who started taking adequate safety precautions from first week of January itself in our institution. Though in the month of January, it was not announced any type of lockdown, but in our college, being a doctor, our pro-chancellor, he is a doctor, so being a doctor, he anticipated some of the situations and started taking safety precautions like sanitization of complete institution campus and other healthy measures. He started taking it from the month of January itself. We all are thankful to him and thankful to our principal also, who immediately conducted meeting with all staff, all students to take adequate necessary safety precautions. And now, as you all are aware that we are confined to our home and that is for our well-being, we must follow the guidelines issued by officials of central government, state government, Ministry of Health and Family Welfare for our well-being. So my dear students, need not to get disappointed. Through these videos, we will be in touch with each other. Okay, and I will be planning for some online classes where we all will sit together through Zoom app and all. We can go for video conferencing and we will have a discussion. Okay, so let us utilize this time constructively and productively. It should be productively also. Some output should be there 100%. Okay, so right, we will go for our discussion. As we have already discussed, I will be discussing about Aeroengine today. Okay, so we will move ahead. Thank you. Okay, so let us discuss on these types of engines which are used in aircrafts. So as you all are aware that piston engine we all have already seen, which we are using in our vehicles, two-wheeler, four-wheeler. Okay, so piston engine are also used in aircrafts, small aircrafts. Then turbojet engine, turbofan engine, turboshaft engine, turboprop engine, ramjet engine, scramjet engine, pulsejet engine. So these engines are used in different aircrafts as per the role of the aircraft. Okay, some are used in fighter aircraft, some are used in cargo aircraft or transport aircraft, some are used in helicopter, like turboshaft engine, turboprop engine is used mostly in cargo aircrafts and all. Okay, and in transport aircrafts, turbofan engine is used in transport aircraft. Ramjet engine, scramjet engine and pulsejet engine are different type of engine. I will be coming out with different videos for each and every engine. Okay, each and every engine is having some specialty and our students, if for their benefit, I will be telling them each and every engine in detail. Okay, so today my discussion will be limited to turbojet engine, which is the engine which is you can say fitted in fighter aircrafts mostly, and the basic. Okay, so the basic engine which everybody has to understand, and then only we can understand turbofan engine, turbosoft engine, little bit modifications are being done. Okay, so as you all are aware, turbojet engine, as I told, that mostly it is used in fighter aircrafts. So turbofan engine are mostly used in transport aircrafts. Turboshaft engine, it is used in helicopter. Turboprop engine, it is used in cargo. Means the engine, the aircrafts which are meant for carrying loads. Okay, ramjet, scramjet and pulsejet are different engines. So it is combined with all other turbojet engines mainly. Okay, so let us have a complete description on turbojet engine today. So a turbojet engine is having different components. It will be having a compressor which will be there in the front. Then the compressor will be directly coupled with the turbine. In between there will be a combustion chamber. Not only one combustion chamber, all around the turbine shaft there will be combustion chamber. Several combustion chambers will be there. Then it will be having an exhaust nozzle. So the major parts of a turbojet engine, what I can say, that it will be having a compressor, then it will be having a combustion chamber, then there will be a turbine and exhaust nozzle. Okay, now let us understand the basic working of this turbojet engine in detail. So the very first arrow which which you are seeing in where I have written this C, okay, in front of compressor. So this portion actually it is called air intake, and air intake is the part of an aircraft. Similarly, exhaust nozzle is also part of an aircraft. They are not the part of an engine. So the air which has entered in the air intake will be going through the compressor. So it will enter the compressor, and in the compressor the air will be compressed. Okay. So the compressor will consist of blades, rotating blades, stationary blades. So a set of rotatory blades and a set of stationary blade, both will be combined together, and it will be called as a stage. So a compressor is made of many stages. Though the compressor are of different types, what I told, it is actually axial flow compressor which I am discussing today, whereas there is centrifugal flow compressor is also there. So there can be many stages of the compressor. So what's the purpose of compressor? The purpose of compressor is to compress the air which has entered in the air intake, thereby reducing its velocity, reducing its volume, and increasing pressure. So the pressure has been increased by compressor. So here compressor is doing work on the fluid which is air here. Okay, then the pressurized air is entering in the combustion chamber. Now in the combustion chamber we do have mechanism to spray fuel in atomized form. Atomized form means in the form of fine droplets. Why we are you can say spraying the fuel in the form of fine droplets? To have a thorough mixing with that pressurized air, and that too in a shorter period of time. Okay, so when we have this thorough mixture prepared in the combustion chamber with high pressurized air and fuel, there will be a mechanism to create spark inside the combustion chamber. That mechanism will be utilized to burn the fuel and air mixture. Now till the time the fuel and air mixture was not burned, the air which has entered in this engine, we call it as air only. But after burning, it has taken the form of a gas. Okay, so it is hot gas now. High pressure hot gas. This hot gas will be having a very high amount of kinetic energy with it, high amount of energy, and it will be coming out and will be entering the turbine. Now the purpose of the turbine is to convert this heat energy gained by the air or developed in the combustion chamber to mechanical work. So the fluid will work on the turbine now. So the hot exhaust gases will be working on the turbine. Turbine also will be of many stages. It will also consist of a set of stationary blades, a set of rotatory blades. So in the form of this also will be consist of many stages, and the turbine will extract the work. Okay. Still, those hot gases will be having much energy after doing work on the turbine also, and as you have seen that this turbine is coupled with compressor directly. So as the turbine rotates, it will make the compressor also to rotate. Okay, then the hot gases will come out from the exhaust nozzle at high velocity. Right? Now let us understand that how thrust is produced. So as I told that after doing work in the turbine, that hot exhaust gases will be entering in the exhaust nozzle, and the exhaust nozzle is designed in such a way that it will further increase the velocity, and with high velocity that hot exhaust gases will be moving out from the exhaust nozzle. It will be moving out to the atmosphere from the exhaust nozzle, and it will create a force as per Newton's third law. As per Newton's third law, for every action there is an equal and opposite reaction. So the force with which that hot exhaust gases is moving out from the engine, the same amount of force will be created, will be exerted on the engine structure. Okay, and this is called thrust. This force is called thrust, which is already we have studied in our previous classes, and also force is equal to mass into acceleration, where m is in kg and acceleration is in meter per square second. Okay, SI unit of thrust is in Newton only. So now this acceleration can be written as v by t, as I have shown you in slide, velocity by time. So in place of mass of the air which has entered into the engine, we will be writing that mass flow rate of air, okay, entering in the engine. So this m by t we will be utilizing it. So mass flow rate of air entering into the engine into velocity will become the thrust. Now we can see clearly that if we want to increase this F, so we can do so by increasing mass flow rate of the air, or by increasing velocity, or by increasing both of them. Okay, so initially we have seen that there are various types of engines are there: turbojet, turboprop, turboshaft. So all are working on the principle of either increasing mass flow rate or increasing velocity. Okay, this turbojet engine, where we do have small mass flow rate but we are increasing velocity. Okay, so thereby we used to gain more thrust here. So similarly in turboprop engine, turboshaft engine, okay, what we are doing, we are increasing mass flow rate in place of velocity. So in this way we are increasing thrust. So this thrust calculation is very important for aeronautical engineering students, okay, because they have to be very clear on this particular part, thrust. Okay, so now this is actually gross thrust. The formula which I have given to you, it is actually gross thrust, and the vehicle starts moving forward due to this thrust force. Okay, so some amount of drag is also developed, which will be subtracted, okay, and from this gross thrust, and that will be called as net thrust. Drag is what? The opposing force when we run. Okay, so we used to feel some type of opposing force with the air which is passing through our body. Okay, so that is called drag force, which is the opposing force. So this is actually F is equal to m into v by t, or m by t into v is actually the gross thrust. So for you can say understanding only I have put here. If we will go in more detail, then thrust itself will get divided between gross thrust and net thrust. Okay, so I hope you have understood the working of turbojet engine today, and we will be discussing other types of engines next time in my next slide. Okay, so thank you very much, gentlemen. Thank you.